So this is college algebra, and we are continuing to talk about analyzing functions, and we're going to do some more examples with piecewise functions, then we're going to talk about some other concepts like maxes and mins and increasing and decreasing. So let's take a look at this graph, or this piecewise function that they want me to graph. And in order to graph this function, remember that there are three parts that you're looking at. So one of your parts is y equals, that's like red instead of black. Let me change it. It is, go back. Okay, so one of your parts is y equals x squared plus 3. And we know what that is. That's a parabola up 3 units. Another part of your graph is y equaling 7. And a third part of your graph is y equaling 2x minus 1. So what we do is we graph the entire equation, the line, in pencil, and then we erase the part that must be erased. So on the other thing we need to focus on is to give great heed to these numbers right here in these parameters, because these are the numbers you're going to want to make certain are in these tables, because those are going to be kind of the pivot point where that's the point where the graph is either going to erase to the left or the right of those numbers. So those numbers are very important. So if I want to graph this parabola, I want to be certain I get 2 in here. So if I have 2 in here, I might want to have a -2 and a 0 and I don't know, maybe a 4. But make sure that you get that x value of 0 in this table. So if I put a -2 in, -2 squared is 4 plus 3 is 7. If I put a 0 in, 0 squared is 0 plus 3 is 3. 2 squared is 4 plus 3 is 7. 4 squared is 16 plus 3, which is 19, which is going to be off the chart. But we can plot this. So -2, 7 is actually going to be off my chart. 0, 3, 2, 7 way up here, and then the other 4, 19 off your chart. And this is what you're going to see is your parabola looking something like that. Now, you're not going to get to have all of it. That's what piecewise functions are all about, is you're going to get pieces of the function. So this one says where x is less than 2 or where x is to the left of 2. So the point 2, 7, which is way up here, okay, we're going to be to the left of that point 2, 7. So actually we have everything, we get to keep everything we have, because that is my, no it's not. What did I do wrong, guys? I went by 2's, didn't I? And that's all right. If this is a 2, then we're good. So everything to the left of 2 is okay. So we do get to have all of that, but the graph extends up off of my graph paper, and that's the part we can't have. Okay, the y equaling 7, okay, your y value is always 7. This is going to be a horizontal line. So we can put any x values we want, but we want to make certain we get 2 and 4. So I don't know, 0, 1, 2, 3, 4. And then every one of these will be a height of 7. I should have gone by 2's on this whole thing. I didn't realize how far off this was going to be. Okay, so up here, 0, 7 is here, 1, 7, 2, 7, 3, 7, 4, 7. And this is my horizontal line way up here at the 7 mark. That's my horizontal line, graphing that equation y equaling 7. Now I only get to have it between an x value of 2 and 4. Between the x values of 2 and 4, and everything else has to go. Between 2 and 4 is all I get to have. Here's my 2 points, 2, 7 and 4, 7. I get to have my graph between those 2 points, so I have to erase this to get it. Oh, I thought it might let me do that, but it's not going to let me do that. So between the 2 and the 4, this is where I get to have my line. It's like it erased itself. Get on there, stay. There it is. All right, then the next one is 2x minus 1. That's going to be a straight line for sure. And we have the parameter of the 4 up in the function where it's defined, so be sure 4 is in this table. Okay, be sure that 4 is in this table. So maybe a 2 and then a 4 and maybe a 6. So if it's 2, 2 times 2 is 4 minus 1 is 3. 2 times 4 is 8 minus 1 is 7. 2 times 6 is 12 minus 1, which is 11. So if I have the point 2, 3, and the 0.47, and then the 0.611, which is going to be way up here, then it's going to be a straight line. Oh, it's hard to get it straight. Straight line like this. But we don't get to have the whole picture. We only get to have it to the right of the x value of 4. So from here to the right is this part of the line. So I must erase the bottom half. Oh, it let me erase it that time. So there is your piecewise function graphed in 3 pieces. Your parabola is the x squared plus 3. The horizontal is where y equals 7. And then the straight line is the y equaling 2x minus 1. Okay, so it takes a little practice. You got to take it slow and easy. Okay, intervals of increasing, decreasing, and constant. You're going to like this. This part's really quite easy. So if we do increasing, decreasing, and constant, I want you to just kind of duplicate my graph. So over here, put a point here. Okay, over at -5, 1. Then a point at -2, 3. Then a point over here at 1, 3. And make this one an open circle. And then come over here at 3, 3 and put a filled circle and come down to 5, 1. And draw lines here and here and here. Okay, so there's your graph. Okay, so the question says, where is this increasing, where is it decreasing, and where is it constant? Okay, so increasing obviously would be the natural thought of going up, and that's correct. And the best way to think about this is if you put like a little toy car on the line, if it's going uphill, then you're increasing. If it's staying level, it's constant. If you're going downhill, you're decreasing. And they want this in interval notation. So you're increasing in interval notation. You're increasing, and these are x values only, between an x value of -5 and an x value of -3. And increasing and decreasing in constant will always be open intervals, meaning you will always use parentheses, not square brackets. Regardless if the point is a filled circle or hollow, you're going to always use parentheses. Okay, constant, remember we said a constant function was our horizontal lines? So for it to be constant, it's where it's horizontal, and these are x values in these intervals. So this is between a -3 and a positive what? 1. Very good. Positive 1. And it's an open circle, but it doesn't matter. It doesn't alter these intervals. And then you're decreasing between the x values of 3 and an x value of 5. So it's that simple. Where is it going up, and where is it going down, and where is it constant? All right, so let's do another example. Kind of duplicate this graph. So let's put the point just like the other one was. Let's go horizontal for a little while. Another point. Then let's make like an arch like this. Okay. And then let's take a diagonal with an arrow. Okay. So we're talking about where is it increasing, and this is interval notation with x values in the interval. Where is it constant, and where is it decreasing? Okay, x values in these intervals, x values. So where is it going up? There's 2 places it's going up, right? If you start over here at an x value of 2 to an x value of -2 to an x value of 0, it's going up there, right? It's going up. So it's going up from between an x value of -2 and 0, and then it's going up where else? 2 to infinity. Okay, so there's 2 locations where it's increasing. There's one place where it's constant. Where is it constant? X values of what? -5 to -2. And where is it decreasing? 0 to 2. Okay? Those are your intervals of increasing, decreasing, and constant. So I told you it's really pretty easy, and it is. Okay, it is. Always open intervals, meaning always parentheses in these intervals. Okay, then we have relative max and minimum values. We really call these local maxes and mins when we get into calculus, where the local low point and high point is, not across the whole graph, but just in certain regions. So for instance, in this one, you have a local min here. I mean, the absolute min is like down to negative infinity, right? But the local min is at this point here. So we have, they're calling it a relative min. So I'm just going to put min, okay? A relative min at the point -2, -1, and a relative max at what other point do you think that would be? 0, 1. Okay, now careful. These are points. These are not intervals. These are actually points on the line. It's hard to tell sometimes between interval notation and an ordered pair point. This is a point. Okay, so then in example 2, we have a relative minimum here and here. Okay, 2 relative minimums. And so we have a relative minimum at the point -1, -2, and at the point, what is that? 4, 0?
Yeah.
Okay, remember these are points. I can't emphasize that enough. These are points. And we have a relative max, where do you think? 2, 3. Okay, so you can see that this is not bad, right? This is really not difficult. So when you jump into those piecewise functions, you're thinking, oh my gosh, this is terrible. And then luckily it backs off a little bit and it becomes a lot easier. Okay, so that should end this section so that we can move on to the next one.